A calorimeter includes 36 grams of ice with the specific heat of ice is 0.5 calorie per gram Kelvin and the melting heat of ice is 80 calorie per gram at -6 Celsius. The calorimeter's heat capacity is 27 calorie per gram Kelvin. Then, the alcohol is poured into the calorimeter at 50 Celsius with the specific heat of alcohol is 0.58 calorie per gram Kelvin, which makes the final temperature to 8 Celsius. Then, the mass of the poured alcohol is. Based on this question, we can conclude that the specific heat of ice is 0.5 calorie per gram Kelvin and the melting heat of ice is 80 calorie per gram and the mass of the ice is 36 gram and the heat capacity of calorimeter is 27 calorie per gram and the specific heat of alcohol is 0.58 calorie per gram Kelvin. To solve this question, we can use the Black's principle. Black principle, or Aisyah's Black, is expressed by Joseph Black. This principle said that by mixing the two substances, the amount of heat that is released substances higher temperature equal to the number of heat received by a lower temperature substance. So, Q release is equal to Q receive, or Q in is equal to Q out. So first, we need to search for the Q release. In this case, alcohol is the one who released the heat. So we can use the formula of Q is mass times specific heat times delta T. So put the number that we already know from the question and we can get the final answer. Next, we need to search for the Q receive. So we need to search for the Q1, which is mass times specific heat of ice times delta T, and we put the number and the final answer is 108 calorie. Next, we search for the Q2. Q2 is because we need to increase the temperature of ice, so we need to use the melting heat. So Q2 is mass times melting heat of ice, and we get the final answer is 2880 calorie. Next, we need to search for the Q3. In this case, Q3 is the calorimeter, so we need to use the formula of heat capacity times delta T, and we put the number and we get the final answer. The final answer is 378 calorie. Last, we need to search for the Q4 because we need to increase the temperature again so we can make the ice into water. So we can use the formula of Q is mass times specific heat of water times delta T. So we actually know that specific of water is 1 calorie, and we just need to put the number and we can calculate, and the final answer is 288 calorie. And based on the Black principle, Q release is equal to Q receive, and in this case I use Q in is equal to Q out. So Q in is Q1 plus Q2 plus Q3 plus Q4 is equal to Q, and we put the number and do mathematics like usual, and we can get the final answer. The final answer, the mass of the poured alcohol is 150 grams. Thank you. 0.01 moles of gas are in tanks with a volume of 100 liters and have a temperature of 87 Celsius. If the acceleration of gravity is 10 meters per second to the power of 2, determine the gas pressure. Based on that question, we know that the temperature is 87 Celsius, and in this case we need to convert the Celsius into Kelvin, so 87 plus 273 is 360 Kelvin, and the volume is 100 liter, so we change it into meters, is 0.1 meters cubic, and mole is 0.01 mole. Based on this case, we need to use the formula of pressure times volume is mole times constanta of ideal gas and the temperature. So we need to put the numbers of pressure times 0.1 meters cubic is 0.01 mole times 8.314 joule per kmol Kelvin times 360 Kelvin, and we'll calculate the number until we get the answer, and the final answer is the pressure is 299.30 Newton per meter to the power of 2, or we can change it into 2.9 times 10 to the power of minus 3 atmosphere. Thank you.